Hello, welcome to Hashtag Math. Math, studied the right way, understanding what we're doing, teaches an analytical approach to problem solving, which literally creates new pathways in your brain. Then, your brain uses these pathways to solve many non numerical problems, even real life, everyday situations. So the question, why math, is answered. Math trains your brain for success. Hashtag Math videos are designed to facilitate that training through lots of guided practice until it makes sense. The idea is that you work until you feel you ace this material. You know the next step, it feels easy, it all makes sense. At that point, you may stop the video and move on to the next one. Let's master the next topic, linear equations in one variable, and have those skills ready for your intermediate algebra class. It will all make sense. We will go through the basics on solving linear equations in one variable, the so-called one-step equations. I include details on how to manage signs and tons of examples in this video. In solving equations, we must concentrate in which operation is being performed to x. Suppose we have a number a. What can we do? We can add that number a to x. We can subtract it to x. We can multiply the number by x, or we can divide x by that number. So if we have an equation, so like x plus a equals a quantity b, the idea is we want to leave x alone. So what we're going to do is do the opposite operation. If a is adding x, we're going to subtract a. So a minus a becomes 0, then plus x is going to be x, and x will be alone. But if we subtract a on one side of the equation, we have to subtract 8 on the other side of the equation to maintain the equation true. So subtract a on both sides, and well, we get b minus a, so x equals b minus a. Let's see this in an example. X plus 3 equals 5. Then what we want to do is subtract the 3 because it's adding on both sides. And then 3 minus 3 is 0, so we're left with x alone on the left, and 5 minus 3 is 2. When we have an equation, the answer is given by a set called the solution set. So we write curly brackets. Inside the curly brackets, we're going to list the solutions we found to the equation. For linear equations in one variable, there's going to be either no solution, one solution, or infinitely many solutions. In this case, we have one solution, and so the solution set is the set containing the number 2. And that's the answer. Now suppose a is not adding to x, but we're subtracting a from x, and that equals a quantity b. So we have x minus a equals b. Because a is subtracting, what we want to do is the opposite operation, so we're going to add a. And of course, we have to add it on both sides. We get a 0 because a minus a is 0, plus x, and then on the right-hand side, b plus a. And so x equals b plus a. In an example, x minus 3 equals 5. I want to get rid of that 3. Because it's subtracting, I'll add 3 on both sides. On the left-hand side, 3 minus 3 is 0, so we have x, and on the right-hand side, 5 plus 3 is 8. So my solution set is the set containing the number 8. In this case, we have a multiplying the variable. If it's multiplying, we want to go with the opposite operation. So we want to divide by a. Then a divided by a is 1 times x is going to be x. So in the left-hand side, we left x alone. And because we divided the left-hand side by a, we have to divide the right-hand side by a also. And then this would be b over a, so x is going to be b over a. For example, if we have 3x equals 6, then what we want to do is divide by 3 on both sides. And then 3 divided by 3 is 1 times x is x, and 6 divided by 3 is 2. The solution set is the set containing the number 2. And the last case is when a is dividing the variable. Because a is dividing x, we are going to multiply by a on both sides, do the opposite operation, so 8 times 8 times. A divided by a is 1 times x is 1x, and on the right hand side we get ab. 1 times x is x, and we solved for x. X is a times b. Example, suppose we have x over 3 equals 5. We want to multiply both sides by 3 to eliminate that denominator there. 3 divided by 3 is 1 times x is x, and 3 times 5 is 15. And the solution set is the set containing the number 15. I encourage you to pause the video at this time and try these 4 examples by yourselves. Then continue watching the video as we're going to practice how to manage signs. In this first example, 54 is being added to x. So we want to subtract 54 on both sides of the equation. So on the left-hand side, we have x, and then 64 minus 54 is 10. And the solution set is the set containing the number 10. For the next example, 8 is being subtracted from x. So we want to add 8 on both sides of the equation. And we're left with x on the left-hand side equal to 10 plus 8, which is 18. And then the solution set is the set containing the number 18. The next example, 4 is multiplied to x, so we want to divide 4 on both sides of the equation. 4 divided by 4 is 1 times x is x, so the left-hand side is just x, and that equals then 5/4. X equals 5/4, and the solution set is the set containing the number 5/4. The last example, 5 is dividing the x, so we should do the opposite operation. Multiply 5 on both sides of the equation. Then 5 divided by 5 is 1 times x is x, and that equals 5 times 10, which is 50. And the solution set is then the set containing 50. Let's refresh now how we add, multiply, and divide numbers taking into account their signs. For addition is called algebraic sum. The first case is when we have two numbers to be added and they both have the same sign. In that case, we add the numbers and keep the sign. For example, suppose you're adding 13 plus 4. Obviously, that is 17. We added and kept the sign, which is positive for both. So the answer is 17. But if instead we are adding negative 13 and negative 4, we still add them. 13 plus 4 is 17. And you keep the sign. Both are negative. My answer is negative 17. Another example, add negative 5 to negative 25. You add 5 plus 25 is 30, and you keep the sign, which is negative. It's negative 30. The next case is when we're adding numbers and they have different signs. In that case, we subtract the two numbers and keep the sign of the larger or the bigger one. For example, 8 minus 3, obviously 5. You subtract. The bigger one is 8, so the answer is positive. Notice that if we write it the other way, negative 3 plus 8, that's still 5. You're going to subtract them. 8 minus 3 is 5, and the sign of the larger one is positive, so the answer is positive. Now another example. Let's add negative 12 to 4. We subtract 12 minus 4, which is 8, and the sign of the larger one is negative, so my answer is negative 8. So negative 12 plus 4 is negative 8. Another example. Suppose we're adding 2 minus 17. We subtract. 17 minus 2 is 15. The sign of the larger one is negative, so my answer is negative 15. One more example. Suppose you're adding negative 4 plus 10. When we subtract, we have 10 minus 4 is 6. The larger one is positive, so my answer is 6. For the multiplication, again, we consider first the case when we have two quantities that are positive and we're multiplying them. When we multiply two numbers with the same sign, the outcome, the answer is always going to be positive. So for example, when we multiply 2 times 3, that is 6. They have the same sign, positive, positive. If we multiply negative 2 times negative 3, and you see the notation there is kind of deficient. You could be confused and do negative 2 minus 3. For that, it's better to use parentheses. So I would write negative 2 times negative 3 in this way, and it is really clear that we're multiplying two negative quantities. Negative 2 times negative 3 is going to be always positive because it has the same sign. So the outcome or the answer is going to be 6, positive. One more example. Multiply negative 4 times negative 20. 20 times 4 is 80. And because the two signs are the same, the answer is positive 80. When we are multiplying quantities and they have different signs, the answer is negative. So for example, if you're multiplying negative 2 times 3, you multiply 2 times 3 is 6, and then negative times positive is negative. So the answer is negative 6. Even if you write it the other way, 3 times negative 2 is also going to be negative 6. Another example, 5 times negative 3 equals negative 15. Different signs when we multiply are negative. When we're making quotients, the behavior of the signs are the same as in the multiplication. If the quantities we're going to divide have the same sign, the outcome is positive. If the quantities we are making the quotient are different signs, the outcome is negative. So positive and negative. Let's see some examples. 10 over 2. 10 divided by 2 is 5. Because both are positive, the answer is positive. We're used to that. But if instead we have negative 10 divided by negative 2, they have the same sign. So multiply those signs. Negative times negative is positive. So the answer is positive 5. If we have negative 10 over 2, then 10 divided by 2 is 5. And we multiply those signs. Negative times positive is negative. Different signs, the answer is going to be negative. The same as if we have 10 over negative 2. The answer is again negative 5. Notice a little bit about notation here. Negative 3 divided by 7 is the same as writing that negative in the front. It's negative 7 over 3. Because a negative quantity in the top, a positive quantity in the bottom, you multiply signs, negative times positive, the fraction 3/7 is then going to be negative. The same if we write 3 over negative 7. When you multiply those signs, the answer is negative 3/7. So we conclude that no matter if the sign is in the top or in the bottom, as long as they are different, the fraction is going to be negative. So negative 3 over 7 is the same as 3 over negative 7, which is the same as negative 3 over 7. Keep that in mind so when we do slopes, you have this really clear. Let's see one example of multiplication of fractions dealing with signs. Let's multiply negative 3 over 7 times 2 over 5 times. Multiplication of fraction is you multiply numerators and multiply denominators. So we would have in the top negative 3 times 2, and in the denominator we will have 7 times 5. So the numerator is negative because negative times positive is negative. 3 times 2 is 6, so the numerator is negative 6, and the denominator is 35. So the answer is negative 6 over 35. And try them by yourselves, or you can continue with me. Let's practice to master how to manage signs. So in the first example, we want to subtract 4 on both sides, and we get m equals 12 minus 4 is 8. So the solution set is the set containing the 8. On the next example, we want to add 12 to both sides. So we get m equals 15 minus 12 is 3. And because the largest one has a negative sign, the answer is going to be negative. So the solution set is negative 3. On the next one, we want to subtract 6 on both sides, and we get p equal to same sign, you add 11 and keep the sign, negative 11. Solution set containing negative 11. On the next example, we need to add 5 on both sides. It doesn't matter, it's in the right hand side, so we add 5 on both sides. We get x on the right hand side, and then 17 and 5 different signs, subtract, you get 12. The largest one is negative. The answer is x equals negative 12, and my solution set is the set containing the number negative 12. On this, we have to divide by 3 to make a 1, but we also have a negative sign, so we need negative 3. And we do that on both sides of the equation. The negative 3 and the negative 3 are going to cancel out. That's how we get the positive x equals 12 divided by 3 is 4. Two different signs, you multiply, positive times negative is going to be negative. So the solution set is the set containing the negative 4. Now we have negative 7 times x equals 0. Same case. We divide both sides by negative 7. Negative 7 and negative 7 cancel out. We get x equals 0. And so the solution set is the set containing the number 0. We divide again by a negative number to make it positive, and 7 on both sides, negative 7. On the right hand side, we get n. Then 21 divided by 7 is 3. And because both are negative, negative times negative is positive, and equals 3. So the solution set is the set containing the number 3. On the next one, we multiply both sides by 18. Both sides by 18. So we get negative times positive is going to be negative. 18 times 5 is 90. On the right hand side, the 18's cancel out. We get a. A equals negative 90. So the solution set is the set containing negative 90. And on the last one, we need to multiply by 8 to get rid of that denominator, but we also need to use a negative sign to make b positive. So we multiply both sides by -8. And we get negative times negative is positive. 8 divided by 8 is 1, so we get b equals 2. 2 times 8 is 16. 2 negatives is positive, so my answer is b equals 16, and the solution set is the set containing the number 16. At this point, I suggest you pause the video, try them by yourselves. I know you can do it. Just don't expect to have the right answer instantly. Give your brains time to think, and you'll get it. Let's start with first example. We subtract negative 15 on both sides, and we get b equal 23 minus 15, which is 8. The solution set is the set containing the number 8. On the next example, we want to multiply both sides by 4. Notice I use parentheses, do not get confused. Then on the right-hand side, of course, I get a. And then 4 times 5 is 20. Positive times negative is negative. So the answer is a equals 20. And the solution set is the set containing the number -20. On the next example, we add 9 on both sides. At 9, the opposite operation, and we get m equals -13 plus 9. You subtract. 13 minus 9 is 4, and the sign of the largest one is negative, so the answer is negative. The answer is m equals -4, and the solution set is the set containing the number -4. In this next example, we want to multiply by 4 to eliminate that denominator. So we multiply both sides by 4. But I have a negative sign that I want to get rid of also. So if I multiply by -4 both sides, then the two negative signs are going to become positive. Negative times negative is positive, and the 4's are going to cancel out. So we get m on the left-hand side. And then 12 times 4 is 48, and negative times negative is positive, so my answer is m equals 48, and the solution set is the set containing 48. Here we must subtract 16 on both sides, and we get a equals 10 minus 16. You subtract. 16 minus 10 is 6, and the sign of the largest one is negative, so my answer is -6. The solution set is the set containing -6. Next example, quite easy. We need to divide both sides by 100. The 100 cancels out, and we get x equals 0. That's it. Solution set is the set containing 0. On the next example, we want to divide by 14 on both sides, and we get k equals. The answer is going to be negative because negative times positive is negative. 126 divided by 14 is 9. So we get k equals -9. And the solution set is the set containing -9. Next example, we add 14 on both sides. And so we get p equals 2. 14 plus 6 is 20. And so my solution set is the set containing the 20. And for the last example, we divide by -11 on both sides. And we get these two cancel out. We get x equals negative times negative is positive, so the answer is going to be positive. 143 divided by 11 is 13. And we get the solution set is the set containing the number 13. I want to clarify a little confusion I usually find among my students. So suppose I'm writing 4/3. That's a number. I may multiply 4/3 times x. Notice that by multiplication of fractions, 4/3 times x, remember the x has a 1 in the bottom, so that by multiplication of fractions is multiplied numerator times numerators, that is 4 times x, and in the denominator 3 times 1, which is 3. So 4/3 times x equals 4x divided by 3. It's the same thing. When you read this, you read 4 times x over 3. 4 times x over 3. When you read this, you read 4/3 times x. But they are the same thing. And when we want to solve for x, when we have this expression or this expression, you might think of them differently. In this case here, you might want to multiply by 3 to get rid of that. And after you do that, the 3 cancels out, you still have the 4, and then you want to divide by 4. That amounts to multiplying by 3/4, which is the reciprocal of 4/3. So why not go straight to this point and multiply by the reciprocal of 4/3, which is 3/4. When we do that and we multiply, the 3's are going to cancel out and the 4's are going to cancel out, and we are left with our single variable x. So make sure you understand this. If we want to solve the equation 4/3 times x equals 5, then what we want to do is multiply by the reciprocal on both sides. The reciprocal of 4/3 is 3/4. So we multiply by 3/4 both sides of the equation. The 3 is going to cancel with the 3, the 4 with the 4, and we get our x alone. Nice there. Remember that below that 5 there's always a 1, and we are multiplying fractions. So we multiply the numerators. 5 times 3 is 15, and 1 times 4, the denominators, are going to be 4. I have not spoken about this yet, but every time you have an equation, the answer you get is a solution to the equation. It means that if you plug in that number into the equation, you should get a true statement. So it is wise to check your solution. That means plug in the result you have in the original equation and look if you have a true statement. That is indeed going to be your solution. So my original equation in this case is 4/3 times x equals 5. We want to plug in 15/4 in for x here. So we do 4/3 times 15/4 instead of x. And we want to find out if that equals 5, this side of the equation. So the 2 4's here cancel out, and we're left with 15/3, and we want to find out if that is 5. And well, of course, 15 divided by 3 is 5 equals 5. So we're sure that our answer is correct, and we may state that the solution set is the number 15/4. Make sure you don't write that 5 over there. That's a common mistake. This 5 here looking at the end, that's not the answer. The answer is the value here for x. Another thing to notice is that our equation was written like 4/3x equals 5. If your equation is written like 4x/3 equal to 5, you might be tempted to multiply by 3 both sides. You would get 4x equals 15, and then divide by 4 on both sides. That's fine, no problem. X equals 15/4. You can do it, but I still think that multiplying by the reciprocal is more efficient. So try to do this example by yourselves. Pause the video and try to solve it by yourself. I hope you did. As before, we want to multiply by the reciprocal of 2/3. So we're going to multiply by 3/2 on both sides of the equation. 3/2. And then the 2 cancels with the 2, the 3 with the 3, and we get x equals, and then we multiply the numerators. 5 times 3 is 15, and the denominators. 7 times 2 is 14. As simple as that. Solution set. Solution set is the set containing the number 15